and begin, talk just a little bit about logistic regression. It's a technique that I use fairly often because it's a good investigative technique. It's a good way of getting into some other ways of looking at things. But there are some rules, and there are some kind of assumptions in logistic regression that are different from the other, kind of the other techniques we looked at, predictable techniques like regression itself. And so I want to mention some of those rules. I'm going to go back over and grab those slides that I used earlier. Okay. Now, one of the things that happens with logistic regression, and I'll be as non-technical as possible. It's a directional technique. In fact, maybe it would be better if I did this on a little bit on the overhead also. So let me get let's all right, let me go back over the overhead. Okay. With logistic regression, essentially it's kind of like thinking about well, we use the simplest version. We'll say we're using one predictive variable and one dependent variable. Now, the dependent variable has to take on values of 0 and 1. And they're for reasons that are related to the fact that we have created logarithmic values. Those values lie between 0 and 1 for this particular technique. And so we code our dependent variable 0 and 1, with 0 being sort of the status quo and 1 being the change. So if we're thinking about, we're going to use, we're going to see if some particular, well, another way of thinking about it is think about a control and experimental group. The control group is the 0 group, the experimental group is the 1 group. And what we're doing is we're saying, okay, if we have predictors of some sort, and for the lack of, just to kind of make it simple, those predictors also take on the values of 0 and 1. They don't have to. The dependent variable has to. Is if, as we think about moving from 0 to 1 on the dependent variable, does that also create a movement from 0 to 1 on the independent variable? In other words, do they move in the same direction? As the dependent variable moves from 0 to 1, does the predictors, and there could be multiple predictors, do the predictors move from 0 to 1? And so it's a directional technique. Now, if we find that these predictors don't move from 0 to 1, let's say we have some that move from, in the opposite direction. It's not like correlation. It's not like, that's a value, that's a valid outcome. this is not a valid outcome. This is an invalid outcome. And if we want to understand what that relationship might be, then we have to go in and recode our dependent variable backwards, 1 to 0, to figure out what's going on with this thing that we thought was invalid. And so very often we will play with the coding of the dependent variable depending upon what the significant variables are, significant predictors are. And so there's a couple of assumptions we make, and I don't know whether that made it foggier or clearer, but we'll see as we go along. Hang on just one second. Where was that? Oh, there I was. Yeah, okay. All right, I'm going to bring up that PowerPoint thing again. In logistic regression, the dependent variable is always coded 0 and 1. And there can only be 2 levels. It has to be a dichotomous variable with only 2 levels. What it does, it generates a directional predictive function to predict the dependent outcome. In other words, it predicts which category 0 and 1 subjects will end up in. And one of the things that it generates is something called odds, an odds ratio, which allows us to say what's the likelihood of someone being in a particular group. And say, for example, I just had a dissertation that finished that one of his outcomes, and he used logistic regression, one of his outcomes said that students that were sitting, or students, well, let me give you one of the outcomes, okay? White students were 1.4 times more likely to be sitting in a classroom of a teacher that received a merit bonus. And so the use of those odds ratios, allows us to put a likelihood of particular outcomes occurring. One of the interesting things was that students that were gifted and talented were 1.6 times more likely to be sitting in the classroom of a teacher that didn't get a merit bonus. And so contrary to some of the belief, it does not necessarily mean that if you have gifted and talented kids in a classroom that you're going to get the merit bonus if you're in, 3rd and 5th grade. It's probably more likely you won't, because those kids can't really demonstrate growth if they're pretty near the top of the scale to begin with. And so we're looking at some of those things that may have created issues with that technique. And so the details of logistic regression, the dependent variable has to be dichotomous. It's always coded 0 and 1. We can reverse those codings if we need to. Predictor variables move from 0 to 1 or low to high. Does the dependent variable move from 0 to 1? It can only predict in that one direction, from 0 to 1. It can't predict backwards. It can't predict in a negative direction. If we think there's a negative outcome that's significant, we have to recode and run the analysis again. There is something that's called beta that's generated by logistic regression. That creates this odds ratio, which allows us to talk about the likelihood of one value on the predictor indicating one value on the dependent. And each of the predictors, and we can put multiple predictors into the model, is analyzed independent of all the others. And so the logistic regression has some rules. The example that I'll be putting up will walk you through JASP, and we'll talk those rules through again as we work through it, so that you can see where how this thing works and how it sort of plays out. And so since we have such a large turnout here, I'm going to not do that tonight. I'll do that in the morning, first thing. And as I'm hoping my machine still works, that's almost like a promise. Do we have someone there that eventually wants to be a teacher or wants to at least think about being a teacher?
She's really excited to be sitting here, so she's all into this.
Ah, good. Well, education is where it's at. That's what you got to do. Everybody learns every day. I even learn, and I'm an old guy, really old. So, you have to learn every day. All right. Well, any questions about chi-square or what we talked about logistic regression? It'll make more sense when we do an example, when I put an example up. And I'll walk through that in a lot more detail. So, I want to, no questions, no comments, no thoughts?
No, it seems pretty self-explanatory.
Yeah, well, as I've said before, they wouldn't let me teach it if it weren't simple. That's, I get the simple stuff. But
hey, you got to have a strong foundation, right?
Yeah. It's the simple stuff is a whole lot easier to explain as simple stuff if you know a lot of the real high-end stuff. Mm-hmm. Because it's all built on simple bricks. There's not a lot of high-end logic in this. It just, you just start layering stuff on top of layering, and that's what makes the complexity. But, the basic roots of everything that we do statistically are pretty simple, pretty straightforward. All right, folks. Well, I guess I'll see you next week. There'll be an example coming. We're going to meet the next 2 weeks, and then that's probably it for the Zoom meetings. Next week, we'll do the logistic regression piece. We'll look at some different ANOVAs, begin to introduce some different analysis of variance, because there's a couple of things that are useful that are different from what we've done so far. And then, the last session, we'll throw a few things out there that we really won't get into, but you need to, we'll just mention them and be aware of them and talk about, things like propensity score stuff and things like that. Stuff that you'll read in medical journals that and they seem to be in a lot of medical journals, but they're not. It's not as high-end stuff as it is, and some of it comes directly out of logistic regression, and some of it comes out of some other things that we've already talked about. But we'll lay out a few concepts in the last Zoom session about that. There'll be a couple more examples that you'll kind of play with. Then there'll be a final evaluation piece, probably due sometime right after Thanksgiving, sort of the first week or so. What would normally be the end of the semester, last week of the semester, or something like that. But yeah, you'll find that not to be, it's not a killer. It's just going back through all this stuff again, and we'll do some refresher stuff on some videos and things like that as we go along.
Did you say you'd be posting an assignment tomorrow too?
Yeah, I'm going to try to get this example of logistic regression up and put a, kind of a. Here's some more. Here's another piece of data to look at. Give it a whirl and see if you can come up with it. Okay. All right, folks. Have a good one.
You too.
Yeah. Get to bed early. All right. Good night.